So today we will be calculating fuzzy logic using a tool that I mentioned yesterday before we end up the class. So we'll be using a tool which is called JFuzzy logic. The JFuzzy tool is very useful. Okay, it's very useful for calculating. So the name of that tool is JFuzzy logic. Can do with this tool. So in this tool you could declare your inputs, declare also your outputs, the output, and also you can do falsification. You can do the falsification, and you can do also the falsification. Okay. And one good thing with this software is that you are able to draw, or you can automate. Okay, you can automate your membership graphs. Okay. Okay, so you can automate the drawing of your membership function graphs. So in this, all the stages in the fuzzy logic can be done actually with this software. So you should be at least aware of how we do programming. So basically this JFuzzy logic tool will ask you to do some programming here, which we will discuss. So let me just open first the problem that we had last time in the fuzzy logic class. Let me just open it. Okay, so if you remember last time we were solving about this system. If you remember this the sample that we had, the problem is about speed control system, right? So speed control system for the car. So we will try to solve this problem using using this tool, JFuzzy logic tool. Then we'll try to calculate it, and we'll try to see if our calculation last time was synonymous, or at least equal, a little closer to the results provided to us by the JFuzzy logic tool. So I'll be writing the steps in the Microsoft Word, and then at the end of this discussion I'll be uploading this in the Moodle, and you can download it from there, and you can do the practice on your own, and you should learn how to do the programming using this tool. I'll be writing the steps here so that you will be guided what to do next. So let me call this one working with or solving fuzzy logic problems using JFuzzy logic. Okay, JFuzzy logic tool. Okay. So this tool is actually written in Java. JFuzzy logic tool is written in Java. That's why you will be seeing later a jar file. Okay, you'll be seeing a jar file version of the program. So jar is the equivalent of exe in Windows. So basically jar files can run in every machine, in Windows, in Linux, and in Macintosh, or with your MacBook. Okay, it runs provided that the Java is installed in your machine. So the only prerequisite is you have Java installed in your machine. That's why let me just write it in here. For the preparation, you have to make sure, okay, you have to make sure that Java is installed in your machine. Okay, no matter what kind of operating system you are running into or working into, as long as you have Java installed, then it would run. Okay, just make sure that Java is installed in your machine. So if you are using Windows, you can go to control panel, okay, and then go to programs. Okay, go to programs. So let me just do it. So type control panel here, and then go to programs, and then you will see it says Java. So Java is installed in my machine here. So for you to know the version of this, you just have to click it and go to general. Okay, you have to go to general and go to about. So you will see it says I'm using Java version 8 update 241. So this is the version of my Java installed here. So if you want to get a copy of this, if you don't have it installed in your machine, go to Google and type Java download. Then it will give you Oracle or Java. Either of the two you can select. Okay, you can go with Java and download it from there. Again, as I mentioned yesterday, if you have Eclipse installed in your machine or Java NetBeans, no need to install Java, because by default these two software or these two programs require Java to run. So no need to problem that if NetBeans and Eclipse were installed in your machines. Okay, and then second, I suggest you have to copy the JFuzzy logic tool, okay, jar file, okay, in your desktop. In the desktop, it's preferred, okay, so that later it's very easy to access it, okay, preferably. But you can't put it everywhere. If you want to put it in Drive C, it's fine. If you want to put it in documents, it's fine. But when you go with the command line, it will be a little bit challenging for you to explore your machine. So you have to remember JFuzzy Logic is a Java based program. It was written in Java, and JFuzzy Logic is accessed in the command line. Okay, so you'll be getting the output in the command line later. Okay, so this is very important for you to get. Let us now proceed to part 1, which is the creation of the FCL file. When you create your FCL file, you can use any text editing tool that you prefer. Let's say, for example, you can use Notepad. Or in my case, I'm using Notepad++. Or any software that you could use to edit text. And then save the file. As in this example, we'll be using the car speed example, so I have to save it as car speed. Okay, don't change the save as type here. Okay, it must be all types, and it has to end with FCL. So let me save it in the desktop. So I prefer that our FCL file should be saved in the desktop for easy access later as we go with the programming and as we access it with the command prompt. So I suggest that we have to place the FCL file together with the JFuzzy logic tool in the desktop together. Okay. So we can now proceed with the coding. As I mentioned earlier, we'll be using the example that we had last time, which is about the car speed system, and we'll be taking all of these inputs, the falsification membership functions, the rule base, and also the defalsification membership function. So in this example, we're going to calculate these given inputs. You'll be given the temperature of 81 degrees Fahrenheit and 23% cover. So let us see, using this tool, what would be the speed the driver should drive based on those two given inputs. So I made a summary of those in our whiteboard. So our inputs, we have temperature of 81 degrees Fahrenheit, and we have the cover or the cloud density of 22%. And I place it in here, the falsification membership functions, also the defalsification membership functions, and the rule based, which we will be working on later. Go back to your Notepad++ or with your notepad or any text editing tool and start typing the commands. So please take note, anything enclosed in this would be comments, okay? These are comments. These are comments. Anything enclosed with this parentheses with stars, we call them comments. So comments, normally we use them to put descriptions to our code if you want to describe the function of a certain line of code and to remind us later what's the code all about. So this is giving more explanation regarding your code. So take note, whenever you see this, I'm referring to comments. So like any programming language that we have, let's say for example in Java, we have the main function, right, denoted by this symbol. In JFuzzy logic, the equivalent of the main function is actually this. Let me just remove this. We have the function block, and then you have to write here the name of your main function or your function. In this example, let's call it car speed. Okay, car speed. So this is the name of your file or your main. You can name it whatever name you want, it's all up to you, but for the sake of this discussion we will call it car speed. So do a practice. Whenever you do an opening block, you have to close the block. So to close it, you have to type end function block. So we close it. Now let's work with the inputs. So to declare the inputs, you have to type the line var input and close it with nvar. Okay, so do practice indentation so that you will be able to organize your code and you will be able to read them properly according to the way they were grouped. So our first input is, let me call it temp, just to make it shorter, and the type of variable is real. So real numbers, you know them, right? So from 0 to infinity and 0.1 with decimal values, it's all up to you. So when we say real, we're referring to numerical values here. And then we have cover. It's also having a variable real. Okay, so this is for the input as we identify them in our whiteboard. So we have temperature and cover. For the sake of making it shorter, I used temp and cover. And of course we have the output, right, which is the car speed or the speed of the car. So var, then we have the output, then close it with nvar. So we will call this speed, then it is also real, because we're working with numbers. Whenever we work with numbers, so the variables will be real. Now, since we identified our inputs and our output, we can now proceed with the falsification. Falsification means converting our crisp inputs into fuzzy values. You know these concepts, we discussed it before. So let me just have to indicate here what is this code all about, so that you will be reminded later what is this. So, inputs. Let me just write in here inputs, and this will be the output. So for the temperature, actually, for the temperature, we can have the input from 0 to 110, right? 0 to 110 based on this. So temperature can accept the value from, values from 0 to 110. So let me just indicate it here so that it will be easy to remember later on. Zero to 110. So for the cover, we have the value range. The value range would be from, based in our whiteboard, from 0 to 100%. 0 to 100%. So let me just write it in here, 0 to 100. So this will be the value. How about the speed? What will be the value range? The value range for the value range will be from the value range will be from 0 to 100 miles per hour. 0 to 100. Okay, miles per hour. So this is in Fahrenheit. Let me just note it in here. This is in percentage, and this is in miles per hour. Okay, so we put the comments so that we'll be able to understand what the code, or what this line of code is all about. So let me save the code. Always practice saving your code to avoid loss of work. Let us now proceed with the falsification. Let me put a comment here. So in the falsification, we have to use the line falsify and the name of the variable here. So you have to see to it the variables that you used for the input should be the same values you're going to use for the falsification. So the argument for the falsify command is the name of the variable you placed or you declared in the var input. So in this case, let's start with temp and then close the block with and falsify. So before I proceed to the code, so the commands that we have to place in the middle, let me also write the falsify block for cover and close it with and falsify. So both of them now were declared here. So to falsify the temperature. So we have to indicate here the terms that we have used in the falsification process. So going back with example here, For the temperature, we have the terms freezing, cool, warm, and hot. So we have these terms, right? So we have the term freezing, cool, warm, and hot. For the cloud cover, we have the terms sunny, partly cloudy, and overcasts. So in this case, we have to declare them within the blocks. So let's start first with the temperature. So for the temperature, let me write the term freezing. Okay. Then we have the other term, which is cool. And we have the other term, which is warm. And we have the other term, which is hot. Same thing with cover. We have the term sunny. We have the term cloudy or partly cloudy. So we just want to write the shorter code, so we just have to write cloudy instead of partly cloudy, just to make the coding shorter. Then the last term for cover is overcasts. Okay, so we now declared our terms, or our classification terms. So the next step that we need to do for these two, the temperature and the cover, is we have to declare the membership functions. So the membership functions, we have to tell what would be the membership function for freezing, for cool, for warm, for hot, for sunny, for cloudy, for overcast. So what would be the membership functions? So refer back to the membership functions here. So for freezing, if you still remember, freezing starts from 0, and then we have 30 and we have 50. Same with cool, we have 30, we have 50, we have 70. If you will notice, freezing is using trapezoid, and also hot is using trapezoid, cool is using triangle, and warm is using triangle also. So this is how we identify the membership functions. 0, 30, and 50. 30, 50, and 70 for cool. For warm, we have 50, 70, and 90. For hot, we have 70, 90, and 110. Likewise, for cloud cover, for sunny, we have trapezoid. We have the points 0, 20, and 40. We have here partly cloudy triangle 20, 50, and 80. For overcast, we have a trapezoid with a point 60, 80, and 100. So how do we place them in our fuzzy FCL file, in our JFuzzy logic program? How do we place this? How do we declare these membership functions? It's very simple. You just have to observe the coordinates. I call them coordinates, okay? Just for plain and simple understanding, we will call them coordinates. So for freezing, for freezing, we have 0. It starts with 0, right? But look at this. It has 0 is located on 1. You have to remember, falsification will have the value of 0 to 1, between 0 to 1, right? So to convert, in this point, to plot the points, we could have the value 0, okay? The first endpoint of this trapezoid is located on 0, 1. So this is the x and this is the y, right? So when we write the coordinates, normally coordinates are represented in the value of x and y, right? The coordinates for freezing 0, 1, space here, 30, 1, 30 and 1. And the last, for the trapezoid, we have 50, 0. How about the coordinates How about the coordinates for cool? For cool we have 30, 0. We have the next coordinate, which is 50, 1. And we have the last coordinate for cool is 70, 0. Next, let's go with the coordinates for warm. The coordinates for warm, based on this example, we have 50 and 0. Then we have 70 and 1. And we have 90 and 0. Right? And the coordinates for hot would be 70 and 1. And 1. We have, no, it's 70 and 0. Then we have 90 and 1. And we have 110 and 1. So we're done with the coordinates for freezing, cool, warm, and hot under the temperature category. Let's proceed to the cloudy, the cloud cover. So the coordinates for sunny is 0, 1. The next one is 20, 1. Then we have 40, 0. Right? 0, 1, 21, 40, 0. Coordinates for partly cloudy, or let me just call it cloudy. So we have 20, 0, space, we have 50. Since it's lying between 40 and 60 here, so obviously speaking, this would be lying on the 50 area, right? So 50, 1. And then we have the last coordinate to form the triangle. We have 80 and 0 for the cloudy, right? So let's proceed for the coordinates for overcasts. We have 60 and 0, because 60 is lying on the 0 axis of the x-axis. I mean the y-axis, 0 on the y-axis. And we have the second coordinate, which is 80 and 1. And lastly, we have 101. So after identifying these coordinates, you can now place them in your code. So I suggest you copy and paste the membership graphs like this in Microsoft Word or any software you like, and try to figure out the coordinates before you go with the actual coding, because this is very sensitive. If you will commit mistakes on this, then the output of the graphs later will be distorted, and it won't give you the right defalsification values. So recheck everything and see to it that all the coordinates were properly done. Okay, 0 1, 31, 50 0, 30 0, 51, and we have 70 0, 50 0, 71, 90 0. We have the next one here, 70 0, 91, and 110 1. Likewise here we have 1 0 on the x and 1 on the y, 20 on the x and 1 on the y, 40 on the x and 0 on the y. Likewise here we have 20 on the x and 0 on the y, 50 on the x and 1 on the y. We have here 80 on the x and 0 on the y. Then lastly we have for the overcast 60 on the x and 0 on the y, 80 on the x and 1 on the y, 100 on the x and 1 on the y. So they are now verified. So upon having this, you can go to your code and actually copy paste everything. Let's say for example for freezing, you can copy this actually. Copy this and try to paste it here for freezing. And make sure you terminate the line with a semicolon. Same for the cool. You can copy this. If you have done it in Microsoft Word, you can simply do the copy and pasting. Pastes, semicolon here. For the warm, just copy this one and paste it here for the warm. And for the hot, we have this, the hot, copy and paste it here. Okay, terminate it with semicolon. Likewise for the sunny, you can go with the code here. Control C, Control V, semicolon. For the cloudy, Control C, Control V, semicolon. And this one. Okay, so let me just put a comment here so that you will be reminded later on what's this line of code all about. So coordinates of the membership graph. Example here, you can trapezoids or triangle. Okay, so this would be the comments here. So everything will be the same for this. Next, let's go with the defalsification. So you know defalsification, right? Converting the fuzzy values into crisp output. So the command that we use, if we can call it command or method, the name is defalsify. Okay, same thing here. In the defalsification, since defalsification is the output, let me just write in here a comment. Let's do the defalsification process here. So we have defalsify, so this will be the output, right? So our output here, let me just also put a comment here so that you will be reminded. Output. So we use temp, right? I mean, not this one, sorry. This is the, sorry for this. Let me just move it here. Okay, so in the diversification, you have to use the same variable used for the output, which is speed. So better copy that and paste it here, just to avoid spelling mistakes. You can do the copy and pasting. Okay, of course, if you have diversification here, I mean the diversify block, you could close it with end diversify. If you will see, this is quite straightforward, nothing much difficult in the coding process. And diversify. So how about the diversification? In the diversification, same with diversification here, you have to declare the terms that you have to use. So in this example, how many terms do we have for the diversification membership function? We only have two, right? Slow and fast. But other real world problems or real life problems will give you as much as, let's say, for example, 3, 4, or 5 outputs. But in this example, we'll be using only 2, slow and fast. So in this case, we only have 2, the term slow. Okay. Oh, I'm sorry for this. I forgot to put the equal sign here. Please make note of that, the equal sign. Don't forget the equal sign here. Okay, we have the term slow, and just put the equal sign here so that I won't forget later. And then we have the term fast. Okay, so likewise, what we have done with this, go back to your graph and try to go with the coordinates for slow. So the coordinates for slow would be this one, right? 0, 1, right? 0, 1. Then we have 25, 1. And we have, don't forget to put spaces, okay, between the coordinates. Then we have 75 and 0, comma 0. How about fast? The coordinates for fast will be the following: 25, 0, space 75 and 1, space, and we have 101. Okay, so check it, verify before you proceed to the code. The coordinates for slow, we have 0, 1, 0, 1, 25, 1, and 75, 0. We have 25, 0, 75, 1, and 101. So if you are sure these coordinates are correct, you can now copy them and paste them in the code. Don't forget to close, to end or terminate the line with the semicolon. Then we have here 25, 0 up to 101. Just copy it and paste it here. Don't forget to terminate it with semicolon. Save your work. Next, we have to declare what method. So what we are using in the calculation last time was the center of gravity, or COG. Is the commonly used method in doing the classifications. Although, as far as I know, the JFuzzy logic tool is supporting various types of declassification methods, but we will be using the commonly used one, the COG, the same thing we have used in our past examples in the calculation. So the default value, the default is equal to 0. Why equal to 0? Because we have slow 0, right? And the max is 100. So we'll start with the default, which is 0. And then we have to declare the range of the possible output. Take note of that. The possible output, we have to declare it 0 space dot dot then 100. Why 100? Obviously speaking, we have 100 here. The range for the output, the possible output, would be 0 to 100, as we have indicated in this variable declaration here for speed. So we have now the pacification. So the next part of the coding process would be, how do we convert, how do we declare the rules? So again, I took a summary of the rules. So we have them here. If it's sunny and cool, drive fast. We have cover sunny, temperature cool equals speed fast. Then if it's sunny and hot, drive fast. Okay, so you know these symbols, we discussed them before. So this represents the and. Okay, this one represents the equal or the then. If you are doing if else statements, then this one is equivalent to then. Or if you are representing this in discrete mathematics, this is equivalent to equal, right? So we have all these rules. You can refer to your PowerPoint in the Moodle, and you may use it as you go with the rules. So we have basically 4 rules here, but in reality you may have as much as 5 or 10 rules, depending on how complex the project you are working with. So how do we declare the rule blocks or the rule base? Let me just put a comment here again for our reminder later. Let me just write here rule blocks. The rule blocks. The rule base. Yeah, these are rule base. So to declare the rule base, we will be using the rule block. Okay, then you have to write here whatever name of the block. In this, let's say for example, let's call it speed rules. Okay, and then close it. Remember, if you have the opening block, you have to close it. It's like in the programming. Open and closing parentheses, open and closing brackets, curly brackets. So in this way, we'll be also closing it. Rule block. Okay, and then if you will see, we have the end function block here. That will be the end of the FCL file. So for the first rule, you just have to write rule 1 for the first rule. If you have plenty of rules, you have to write rule, then 2, rule 3, rule 4. In this example, we only have 4 rules. So you just have to represent this if cover, sunny, temp, cool equals fast, right? So how do we represent it in JFuzzy logic? If, close parenthesis, cover is sunny. So look at this one. The variables that you're going to use for the rule block, for each rule here, should be the same variables you have declared. If you will notice, when I use the Notepad C++, when I click cover, it will highlight all the similar words, right? So, and also when I type the words here, it shows automatically, meaning the words I used in the past. So take note, the same variables that you have declared will be the same variables you're going to use in the rule block. Okay, so and this one here is equivalent to and then we have close parenthesis temp So temp is showing because I used it before. Click it. Is cool. Okay. And then speed is fast. So it's like you're writing a sentence, right? It's if cover is sunny and temperature is cool, then speed is fast. It's like you're writing a sentence, so not much difficult to comprehend. So the next rule, okay, so the next rule, which one? The next rule is cover sunny, temp hot. If cover is sunny and temperature is hot, temp is hot, then speed is fast, right? Speed is fast. Next, if and then what's the third rule? The third rule we have cloudy, cover cloudy, temp warm. Cover is cloudy, temp is warm. Then what happens next? Speed is, according to the rule, speed is slow. Then last rule we have if close parenthesis and close parenthesis, then just check it out. Cover cloudy, cover is cloudy, and temp is cool, right? Then speed is slow. Okay, so this is how we wrote the rule base. So assuming everything is fine and correct, then you're ready to run the code, and let's see the output. Let's hope and pray that there are no mistakes, or there are no mistakes in this code that we have written, or else we're going to recode and debug it and locate where the problem is. So let me check again. Cover is sunny, temperature is cold, then speed is fast. Cover is sunny and temperature is hot, then speed is fast. Then we have if cover is cloudy and temperature is warm, then speed is slow. If cover is cloudy and temperature temp, look at this one, temp is cool, then speed is slow. So let's save the work. We are done now with the rule block, and before we proceed to the next step, let's try to see first if there is no confusion between our rules and our variables, because sometimes it happens all the times, and most students, they commit mistakes on this. So look at this one. We have the rules here. It says if cover is sunny and temp is cool. So our rule base is expecting that the first value that we input refers to cover. But in our variable declaration here, we have our first input as temp, right, which is temperature. So it will be conflicting with our rule here. So it says here cover is the first argument. The first argument for the if statement is the cover, and the second argument is temperature. But in the variable declaration, the first one is temp, which is actually the second in the rule, and the second one is cover, which is first on the rule. So you have two options here. So the first option that you want to make is you switch these two, put cover in place of temp and temp after if. So it would be a little bit complicated for you. So instead, I suggest, why don't we just switch the two variables here? So take cover from the top. Take cover, put a space in here, take cover and place it here, right? So that you will see cover, temperature second, and second is temperature. So you have to see that the inputs here, the order of the inputs match with the order of the arguments in the if statements in your rule base, or else you'll be committing, or you'll be having erroneous outputs in the falsification later. And before we proceed to running this code, let's try to check what would be the possible mistakes that we have in here. So this one, everything is close y semicolon. This one, so we have to put equal here, and okay, this one has no semicolon. So please check, okay, all of the possible mistakes here. So don't you worry if you have mistakes. Your fuzzy logic tool will show to you which line of the code is having a mistake. Okay, so it will tell you which line. So that's why it's very helpful to use this kind of text editing software, because it tells you the lines, right? So basically, if you have mistakes in your code, the JFuzzy logic will tell you which line here is having a mistake. So let's proceed to the next step, which is running your fuzzy logic file. So before I proceed to this, let me write a note. So the jar file, okay, so when I say jar file, I'm referring to the JFuzzy logic tool here, okay? And tool, and the FCL file, the codes that we have written earlier, should be on the same location, or let's call it folder or directory. Okay, so the next step, let me just write in here, sex, open the command prompt. Okay, how do you do that? Go to start, then type cmd. And then select it from the list. Let me just save it later. I'll give it to you. So go to start and then type cmd. It will be listed here. Click it to show it. Let me just minimize it. Let me write the succeeding direction. So since the files, okay, the jar file and the FCL file are in the desktop, in the command prompt, switch to the desktop by, of course, typing the command, this one, cd, just stop capitalizing, then desktop. Let me just change the font here so that you'll see what time. To denote code, I'll change the font. Okay, let me change it to Korean New. Okay, so let me just type it. Let's go with this one, which is CD, then desktop. So we will be switched to desktop now, and then for us to run the code, the codes in the FCL file, in the command prompt, run or type command. Okay, just type it in here, Java -jar, just running a jar file, which is JFuzzy logic.jar. So please check it. It should be in the desktop. This one, okay, JFuzzy logic and the car speeds. Java -jar JFuzzy logic.jar. So you have to make sure that the spelling is correct, okay? -e meaning execute. The file name here of your FCL file, and then you have to type the inputs here: input 1, input 2, input n. If you have plenty of inputs, you have to write the inputs here, okay? So some examples or some problems might ask you to provide many inputs, but in this example we only use 2, correct? So example, in this example we have Java -jar JFuzzy logic.jar -e. The file name is what? It is carspeed.fcl. And what will be the input? We have, please check the code here. The code here says the first input is cover and the second input is temperature. So meaning we need to write the first input for input cover, and the second input, you have to make sure they are separated by spaces here, input for temperature, okay, as indicated in your code. So we have 2, right? Cover and temp. So in the example that we had in the whiteboard, we have this: cover is 23 and temperature is 81. So we have to write here, let us just replace this, okay? Just replace this one. The input for cover is, as per the example, is 23 and the temperature input is 81. Let me just change the font so that you will know these are codes. Okay, this one, Courier new. So Java jar JFuzzy logic.jar -e car speed FCL 23 and 81. Okay, let's copy this. Let's copy this one and paste it in the command prompt and press enter key. So this is the output now. Okay, so based in this, so we have the following. For the cover we have 23 indicated by this line, and for the temperature we have this line which is representing 80, right? And the value for the speed, according to the calculation using center of gravity, we have speed is 63.06 miles per hour. So this is the output. So this is how you interpret the output here. So var input cover 22%, var output speed 63 point something, and then our var input is temperature, which is 81, so we were given this output. Okay, so this is it. So just to remind you, in your comprehensive assignments, you have to provide screenshots of everything and explanation of the source code here. So this is the end of today's session, and I hope you could practice this at home. So don't forget all the steps here. Anyways, I'll give you a copy of the manual in the Moodle. Thank you so much and goodbye.